Hello guys, Matt is back with another video, and today we are on problem 7. Problem 7 of our series wants us to find the 10,001 prime. We're seeing prime numbers for the second time in the series. Should be easier the second time around, right? I hope so. So for all the new people, if you haven't already subscribed, please click on the subscription button below so you get notified whenever I release a new video. I'll be releasing a video every day. Watch the space. Let's go. The problem definition states, by listing the first 6 prime numbers, 2, 3, 5, 7, 11, and 13, we can see that the 6th prime number, the 6th prime is 13. What is the 10,001? We'll be looking at that. So we already know that we need some kind of a helper function to find out if a number is prime or not. We looked at 1 in I think it was problem 5 or 4. I don't remember. I don't quite remember which problem it was. But we looked at 1 where our code didn't actually run. So it wasn't an efficient way of doing it. So today I'll be showing you a more efficient way of finding out if a number is prime or not. So I'll actually leave a link below for you to so you can have a look at it. Yeah, so you can have a look and get to know more about prime numbers and why they work the way they do. So let's write our helper function. So I'll call that function is prime. So this will be the function we'll be using to find out if a number is prime or not. So first of all, we know that 1 is not a prime number, and anything less than 1 is not a prime number, right? So that means we have to say if n is less than or equals to 1, then we need to return false because we know that that is not a prime number. So we can return false for that. And one other thing, we know that if n is 2, then 2 is a prime number. So 2 is the only even number that is a prime. So we can actually have a special condition for that. We can say if n is equals to 2, and then return true. No other even numbers are prime numbers. So we can actually stop it there. So if n is divisible by 2, then we want to return true for this one, because we know that no, we want to return false because all other even numbers are not prime. So maybe we can try and combine these 3 if statements here into one. If we can, we'll try that after we solve the problem. In the end, let's just continue here. Maybe we'll try and simplify these statements if we can. So now we know that we're looking at numbers from 3 upwards. So we'll start off with I'll just call our iterator. We'll be using I as our iterator. I'll be using a while loop to try and find out if a number is prime or not. There's this notion about primes that you actually don't have to look at all the numbers. So let's say we're looking at 5 to find out if it's prime. We actually don't have to look at 1, 2, 3, 4 to know if that number is prime or not. We actually can look at the square root of 5. So we can stop as soon as things are greater than the square root of 5. We can actually stop iterating. We know that by that point we can know that that's a prime or not. So you can see that in the link I'm going to leave in the comment section down below. So just have a look at that. Yeah, we're going to use that notion to solve to find out if a number is prime or not. While I is less than the square root of n, then we can actually look at the numbers that are less than the square root of n. So there is the math class that we can use to find out a square root. which is that. So that's the square root of a number. So while that's less than the square root of n, then we can look at those numbers there. So what do we do in this case? Then we can try and find out if the number is prime. So if our number is actually divisible by I, then we know that it's not a prime. So we'll return false in this case. So we stop. Otherwise, what do we want to do? We want to look at the next number. So what is the next number? We already know that if by looking at this case over here, case number 2 will discard all even numbers. So since all even numbers are discarded and we're starting at 3, if we add 2 to it, we'll look at 5, the next odd number. So we want to look at the next odd number. So by doing that, we can actually just do that. And then now we're looking at the next odd number and trying to figure out if that one is prime. If we make it out of the while loop without returning a false, that means this is actually a prime number. So we can return true in here. So yeah, this is our helper function. So we're saying if n is less than or equals to 1, we return false. Otherwise, if it's 2, return true. Otherwise, if it's an even number, return false. Then we can start looking at it. So we're discarding a lot of numbers before we actually start. And by using this one, we're not going to look at more than half of the numbers that we were looking at in the previous video when we first looked at primes. So this is a much more efficient way to find out if a number is prime or not. So let's just test it out. So I'll console log. So I'll say it's prime. And then we'll check for 2. Let's check for 2 to start off with. And then it says it's true for 2. Let's see for 3. It says it's true for 3 as well. Let's check 5. So it works for 5 as well. Let's check 15. Let's check 15. And 15 is false. So it's giving us the right answer at the moment. So now let's try and solve the problem. So how do we solve the problem? We need to. So I don't know how to find a better solution at the moment. So I'm going to use brute force, which is I'm just going to find the first 10,000 primes and then find the next one, which will give us our answer. So that's the approach I'll be taking in this video. So I'll call my function find prime and find prime. Let's just I'll call the input search, which is a number. So we're looking for the prime, the number at the search. So search will be the position of the prime we're looking at. If we want the first prime number, we'll give that the search variable, we'll give it 1, and then we'll move. If we want the third one, we'll give it 3. If we want the fifth one, we'll give it 5. That's what the search is for. So let's start off with our prime count. We want to find the 10,001 and first prime. So we'll assign that to 1, and then have our iterator. This we'll be using to iterate through our numbers to find out if it's prime or not. So I'll also give that 1 to start off with. But while our prime count is less than our search, once we get the prime at that position, then we should stop. So I'll say while our prime count is less than our search, then we want to look for our prime. And since we are starting off at 1 over here, The reason I'm giving this one is because we start off with, we know that we already have our first prime number, which is 2. And then I'm giving this one because I'll be iterating through the only the odd numbers, because I will not be looking at 2 in this case. That's why these variables are initialized to these values. So while this is the case, I want to give my I want to change the value of my I by 2, right? I want to change the value of my I by 2 because I'm skipping 2 to start off with, and then after that, I know I already have my 2, so I only look at 3. So we don't want to double count. So that's why I'm adding in the beginning and not afterwards, right? So yeah. So now I'll go if our number is prime, if I is prime, then we actually want to what? We want to increase our prime count. So we found a prime number, so then we increase our prime count. And then when we're done, we know that we found an I at that position in our search that is prime. Sorry, that is prime. So I can actually return I to us. By doing this, we can find a prime at any position. So now let me just I'll find prime. So let's try and find the sixth prime. So the sixth prime should give us 13, like they said in this case. So let's give this guy, sorry, not 5 but 6. Let's see if we should get 13. We got 11, not 13. We got 11, not 13. I wonder what's wrong. So we got 11 for this. We shouldn't be getting 11. Let's see what is wrong here. This one over here looks good to me. Oh, I see. So we should actually be looking at I less than or equals to the square root of n. So if we change this should be, I think this should be okay. So let's try run our code again. And then now we get 13. So this is what we expect. So since we're getting the correct one for 6, let's check for this guy over here and see if we get the correct answer. Let's test it out. So always remember to log in over here. And that is the correct answer. So yeah. So I'll see you in the next video.